Okay, friends. Kind of short notes today. We actually broke up the next couple days. They're kind of short, where we'll have the opportunity to work in class and practice. The reason why we broke it up kind of short is because we're kind of taking smaller steps to make sure we have a pretty good understanding. It's still the graphing of the quadratic, so that's something that's raised to the third power. But this says Vertex Form. So we have something in standard form. And let's walk through this first problem a little bit. And I need myself a graph. All right, so let's go math, graph, Cartesian. That should be good enough. We'll move it over here so it mimics our notes a little bit. All right, so they tell us that we have x squared plus 6x plus 5. Is that right? So that's the equation. And actually, if we wanted to make this correct, where we say that it is a parabola, I'm going to go y equals. That way that says, hey, I'm going to use both the x and the y axis. Is that okay so far? So a few things about this problem before we answer questions. Some of you might see that, hey, can this factor? Let's see, my magic number is 5. Factors of 5 that add to 6. 1 and 5, right? So this will factor to x plus 1. Oops, I didn't want that. X plus 1x plus 5x plus 5, right? Factor that out, x plus 1. And then that's a 5 and x plus 1. And so then it factors to this. So this is the factored form versus the standard form. Agree? What does the factored form find us every time? The roots. Okay? So the roots will always be opposite of this. So this is going to give me what for an answer? Negative 1, 0. And this gives me what for an answer? Negative 5. So if you go from standard form to factored form, if it factors, you can find where it crosses the x-axis. Halfway in between these 2 points, we will indeed get our vertex. Okay? But another way that we could look at this is said, well, I did have this, and I know my a value is 1, my b value is 6, my c value is 5, and if I go x equals negative b over 2a, I'm going to get negative 6 over 2 times 1, which is negative 3. So I have an axis of symmetry at negative 3. And somewhere up and down that line, I will have my vertex, and I can find my vertex from plugging negative 3 back into either my original here or the factored form. It doesn't really matter which one you pick. So if I plug negative 3 in, negative 3 squared is 9 minus 18, because 6 times negative 3 plus 5. So 9 added to 5 is 14. Negative 18 plus 14 is negative 4. So I get negative 3, negative 4. And I have my vertex. Okay? So the answer to letter A, this is the answer to A. This here is my vertex. That's the answer to letter B. The y-intercept. Now, a couple people struggled on the y-intercept up here. And I kept saying over and over, what's the y-intercept? 0, comma what every time? C. What's my C value? 5. My y-intercept is 0, comma 5. So that's 0, comma C. And you get C from standard form. So in this case, it will be 0, comma 5. Okay? And then the roots. We just already said that. It said, hey, I got this root. And I got this root. And then I guess I could say, hey, I got this other point over here that exists because it has to be symmetric. But here's my parabola. Okay, so a couple things that we took apart on this problem is I recognize it's possible that we factor it. If we factor it, we can find the roots really easily. If I can find the roots, then I know halfway in between the roots is going to be the axis of symmetry. And somewhere on the axis of symmetry is going to be the vertex. We can find, if it's in standard form, we can always find where it crosses the y-axis, because that's 0 comma c, which the c value is the number that doesn't have a letter attached to it. Is there anything about this problem that you have questions on? Does it pattern graph? Yeah, this should have went right one up one. That should work. And left one up one. And then right one up 1, 2, 3. That worked. Here. Cool. So pattern graphing will work with the 1, 3, 5. I did have a couple people on this quiz, not in this class, next period. They were giving me straight lines. Man, there's nothing about this tractor that has a straight line other than the axis of symmetry, right? So I guess I didn't teach him as well as I taught you all. Okay. Yes?
What were the roots?
The roots are where it crosses the x-axis. So we got the roots from where it factored, because I would go x plus 1 equals 0 and x plus 5 equals 0. So solve each of those just as a one-step equation. And you get this is a root and this is a root. So a root is the solution of the problem, meaning if I plugged an x value in, I get a 0 out. We good? Yeah.
So was negative or negative 4 plus vertex?
Yes, negative 3, negative 4 is the vertex. So I know I have it up here, but the vertex is down here, right? Hey, is that vertex at a maximum or a minimum?
Minimum.
Minimum. And so right there, that's my minimum value. Okay. What'd I do?
I have a question actually.
Talk to me.
Can you show me how to get the y-intercept?
Y-intercept? You see my original equation, x squared plus 6x plus 5?
Yeah.
So 0 comma c. C happens to be 5. So 0 comma 5 is my y-intercept every time.
Why is it 0 comma c?
Because you're constant. So your y-axis is an x value of 0. So 0 comma. So if I plug 0 in, 0 squared plus that gives me 5. That's all it is. Yeah.
So if I just put 5, like y equals 5, is it wrong still?
I would give it to you right now, but I'm eventually wanting you to direct you to give it to me as a point.
Okay.
May I move to the next problem down?
Yeah.
Is that one done a little bit different?
Yeah.
What form is this one in?
Oh, it's in the parentheses.
Is this in standard form? Or is it factored already?
It's already factored.
It's already factored, right? Okay. So this is already in factored form, agreed? So let's figure out where my roots are because it's in factored form. So I'm going to say x is equal to 3, so that's 3 comma 0. And x is equal to negative 1, so that's negative 1 comma 0. So I get 3, 0, and negative 1, 0. Okay, so if it's already broken down, it'll tell you where it's going to cross the x-axis as roots. So that's 3 comma 0, and that's negative 1 comma 0. All right. Is positive 1 right in the middle of those?
Yeah.
Appears to be. It's 2 away, 2 away. Does it make sense? So my axis of symmetry is x equals 1. Okay? What happens on the axis of symmetry? What always happens on the axis of symmetry? What? Plug it in to find what? The vertex, yeah. So if I want to get my vertex out of this, I don't have to go multiply my thing out. I can just say, well, I know at 1 comma something, because that's actually my negative b over 2a, even though it's not in standard form. It's in factored form. So I have a 1 that works because we found it was halfway between my roots. So I take 1 and plug it in. I get 1 minus 3, which is negative 2. And 1 plus 1 is 2. So I get negative 2 times negative 2. That's 4. 4 times 2 is 8. 1 comma 8, so 6, 7, 8. It's like up here. should this parabola be opening down? Yeah, what sticks out that says it's opening down? The -2 out in front. Yeah.
Why would you multiply the -2 into, like, where do they come from?
So I take 1, that's x. I'm trying to find y. That's my question. So 1 minus 3, -2. 1 plus 1, 2. -2 times -2 times 2. 8. Okay. Let's see. Vertex, y-intercept, roots. Oh, okay. Let's see. So this is going to come down this way as far as my graph. I have my roots and I have my vertex. How would I find my y-intercept? And this is, Sophia, you just asked about this. Remember I said I want you to start making this a point? This is y. My y-intercept happens at 0, comma something. It's 0, comma c, but this is not standard form, so I can't find what c is right now. Agree? Does that verbiage make sense? So I'm going to take 0, which is an x value, and I'm going to plug it in. So 0 minus 3 is -3. 0 plus 1 is 1. And then I had that -2. So what would my y-intercept be by that math? Well, -2 times -3 is +6, and +6 times 1 is like 217,411, isn't it? No, it's 0, comma 6. Okay? Yeah.
I'm still stuck where you got the vertex.
The vertex, okay. So I had my roots.
Yeah.
Good. Right in the middle of them is the axis of symmetry, so in this case it's 1. Okay, so I take that 1, that's the x component of my vertex, because the vertex always falls on there. So if I take 1 and plug it in, 1 minus 3 is -2, 1 plus 1 is 2, and then -2 times -2 is +4, times 2 again gives me +8. So I'm just plugging in my 1s here.
Oh, okay.
So
So you don't add both of the things that you multiply?
I plug it in here and plug it in here, and then I multiply all the way through once I plug it in. Once I get through the little math. All right, axis symmetry, got it. Axis symmetry is right there. So I'll go here. So AOS is that. We have it. Vertex, got it. Y-intercept, got it. Roots, we got it. Those are both my roots. Yeah.
Wait, to get the y-intercept at 6, did you add -2, -3?
I multiply them. I went -2 times -3 is +6 times 1. Okay. We good so far?
Yeah.
So we're done with the front page, right? Okay. I'm going to do a third method, and the third method is often what is used in calculus, and what a lot of times we direct any of our math classes to prepare you, no matter how many years away it is, that you would do this the same way in calculus. And the last thing we're going to talk about with these is called vertex form. Now, if you allow vertex form to scare you, don't. It actually is the most logical of all the forms. For some odd reason, some teacher at some point out in life sucked at math, and they scared everybody from vertex form for whatever reason. Okay? So if it's in vertex form, what do you think it gives you, Ethan?
I do not know.
The bird.
Oh, maybe if you had your phone not in your hand and were paying attention, maybe. What do you think? Vertex form. What's it going to give you?
The
Yeah,
vertex.
it's going to give you the vertex. Exactly. It's going to say, here's the vertex. If it gives you the vertex, you can figure out what the axis of symmetry would be, because that's always the x component of it. So we're going to write this as a general form. Okay. Now the great thing about this, does everyone agree that in math, if you have pictures, they can shift right, left, up, and down? Does that make sense? So this is the foundation. It's always going to be the same. If you have something grouped, it's going to shift right or left. If you have something that's outside of it, being added or subtracted, it's going to shift it up or down. So if I have something in vertex form, it's going to say, hey, my vertex will always be this. H, make it better, H than that. H, comma, K. So it's opposite of that. It was a negative H, now it's going to be positive. H, comma, K. That okay? So that's what vertex form is going to do. Now again, they make this as a frightening thing. Can I show you the scary? And then I'm not going to use any type of calculator to do it. Can I show you it? Put your pencils down. You don't have to know this yet. Okay? So, changing from standard form to vertex form. So standard form is this. And vertex form is this. So converting this to this. That's all we're doing. So let's make something up. Might as well make it nasty looking, because I ain't afraid of no fractions. Though some people are. Okay? Now, you haven't seen a parabola this nasty ever. I haven't given you this problem. It won't factor. Okay? When we find the vertex, it's going to happen like at fractional amounts. That's just plain nasty. All right, you should not be writing this down. First thing I'm going to do is I'm going to divide everything by 3. And I'm going to leave it as a fraction. Is that okay so far? So I divided everything by the a value. That's all I did. Cool? We good? You ready for the most traumatic event in math ever? This is the most mathematical lingo I know how to use. I'm going to make a space. So tell me if you can see where I made a space. What do you think?
Between the 5, 3, and the 7, 3.
Yeah, between the 5/3 and the 7/3. I made a space. There's really no math idea of why you do this. It's just you make a space. Okay? So I'm going to bring this down a little bit. So it's going to work this way every time. So I'm going to change this to this. Okay? Watch how easy it is. Now let me back up a little bit. If I take half of a fraction, can I just double the denominator? I take half of a fraction, can I? So if I wanted to have if I had 1/8 of a pizza, if I double the denominator, that means I'd have 1/16. So I'm making each slice a little smaller, right? So if I double the denominator. So I'm going to take, what is half of 5/3 by doubling the denominator? 5/6. 5/6. Okay? Now, here's the direction we'd go. We're going to go half here, and then I'm going to take this value and square it. So 5 times 5 is 25. 6 times 6 is 36. If I add it, I also have to subtract it from the same side. Now, this is kind of the silly thing I'm at. I'm acting like the federal government. I'm taking money from over here and I'm putting it over here saying, hey, look how well this is doing over here.
Oh, Robin.
Yeah, Robin did too, yeah. Okay. So, here's really the neat part of this. This portion here, if I took x plus 5/6, and I have 2 of them, and x plus 5 over 6, and I FOIL them or I double distributed, it would give me x squared plus 5 over 3x plus 25 over 36. Simple as that. Common denominator here, I'm going to multiply by 12 because that common denominator is 36. So 7 times 12, that's 84 minus 25 over 36. So that's going to give me 84 minus 29 or 25 is 9. Is that 59 over 36? Almost done. Remember this 3 right here? I'm going to multiply it to all of my terms. It comes here and it comes here. If I multiply this by 3, I can just divide that by 3. I get 59 twelfths. So my vertex of this parabola is negative 5 over 6, 59 twelfths. I would never ask you to graph that. Okay? So the thing is, there is a whole bunch of arithmetic that took place to get here. This is where we're heading. I won't give you nasty, ugly things like this yet. Okay, you have some time. All right, so let's talk about the K changer. 1, 2, 3, 4. Yay. The K changer. So if I had y equals x squared plus 3, and if I had y equals x squared minus 2. Okay, let's draw the parent function in first. The parent function is the most basic version of this. So in red, I'm going to draw y equals x squared. If I plot y equals x squared, 0, 0, pattern graph this way, pattern graph this way. So this red one is our parent function. This is the most basic parabola we can have. It's known as a parent function. Let's do this one in blue. All this is going to do, it doesn't have a b value, does it? But it moves up 3. So if that one moves up 3, what do you think that last one does?
Move down 2.
Move down 2. Doesn't have a b value still, so move down 2. Still pattern graphs the exact same. So the red one's the parent function, y equals x squared, that's most basic. If I had x squared plus 3, the blue one is the answer. The black one is the one that subtracted 2. So that is the k value. This right here is a k value, as well as this. Okay? The k value moves it up and down if you're in vertex form. That all right? Can I move on?
Yes.
Thank you very much. Let's look at the H changer. So the H changer is when it's grouped. So I have y equals x plus 3 quantity squared. And I have y equals x minus 2 quantity squared. So I'm going to draw my parent function in, y equals x squared, bless you. Again, this is the most basic parabola that there is. So, anytime things are grouped in math, it's going to do the opposite of what you should think. If it's grouped, this one's going to shift it left 3. It's still going to pattern graph the exact same way. So if it's grouped, it shifts the opposite way that you would think. How do you think the bottom one's going to shift then with that knowledge? If it's grouped, it's going to shift right or left. So this one's going to shift right. How many? 2. So the red one's our parent function. The blue is the shift left because it was x plus 3. The green is the shift right. Do you see how it goes opposite of what you'd think? And it will do that every time. Anything in math, anytime it's grouped, it's going to shift right, left. Anytime it's going to shift up or down, you're going to add or subtract something to it. It doesn't matter which function in math you're dealing with. And then let's look at the A changer. The A changer is the thing that changes your pattern graph. Can I move off here? Oops, I didn't want that there. Seems good enough. All right, so I'm going to graph y equals x squared. That's our most basic. And recognize that we're plotting by 2's. So let's say we have the A changer. This is y equals 3x squared. And this is y equals negative 2x squared. This still has a vertex here. This is going to not grow at 1, 3, 5. It's going to grow at 3, 9, 15. Look how skinny that is. It's skinny because I had a vertical stretch of 3. Changed my pattern graph. This one, though, my 1, 3, 5 is going to change to negative 2, negative 6, negative 10. I still have a vertex right here. And go right 1, down 2. It gets there, and down 2. So flipped it upside down. It's still pattern graph the same. Okay? So that's all we're doing. Now, I'm not asking you to put things in vertex form yet. And I would never have you work in here where you're getting a negative, ugly fraction vertex. Okay? But if you practice these, and I think some of you are starting to get into the practice of, well, just come into class and do it real quick. And then you're saying, oh, wait, my scores are dropping a little bit. Duh. So, number 8. So this is, I'm in the wrong place. What chapter we in? Don't like, so find out. Graphing quadratics, yay.
Pop.
Okay, page 75, 76. You have the remainder of the period to start working on it if you'd like. Okay, and again, guys, girls, if you are at the point where you're saying, I'm not going to do it at home because it doesn't really help me, I beg to differ. Okay?